So section 2.3 covers writing equations of lines. So the point-slope form of the equation of a line allows us to find the equation for a line just given the slope and a point on that line, okay? And when we plug in the point and the slope, this will simplify down to slope-intercept form, which is y equals mx plus b. This is what we want, right? Because it tells us a lot about what the graph of our line looks like. It tells us its slope, and it tells us our y-intercept. So why don't we work through quite a few examples using point-slope form. You will need to memorize and know how to use this, but I'm sure once we work through quite a few examples, it'll be hard to forget. So first thing I want to do is I'm going to write the point-slope form of a line with slope m equals 2 that passes through the point when x is -1, y is 3. So why don't we go ahead and pop over to a clean screen where I can solve this. So I have y minus y1 equals m times x minus x1. I was given a slope of 2 and a point of -1, 3. All I'm going to do is use substitution to plug in my slope and this point. So I have y minus 3 equals 2 times x minus -1. Two negatives give us a positive. And then I can go ahead and distribute. That was supposed to be an x. 2x plus 2. I add 3 to both sides. Now I have a point-slope form of my equation. Y equals 2x plus 5. Okay? So given us our slope and any point on that line, I can find the equation for that line. Let's work through another example. I want to write the point-slope form for the equation of a line with slope -1/2 that passes through the point 5, 2. So why don't we go ahead and flip over to a clean window and I can work through that problem. So I was given that m equals -1/2 and my point on the line was 5, 2. I'm going to go ahead and set up the point-slope form of my equation. I'm going to take y minus y1, that equals my slope, times x minus x2. I'm going to go ahead and distribute my slope, so I have -1/2 x plus 5/2. I'm going to add 2 to both sides. I get y equals -1/2 x plus 5/2 plus 2. Now in order to add fractions, they have to have the same denominator. So I need 2 to have a denominator of 2. I'm going to do that by harnessing the power of 1. See, I multiplied by 2 divided by 2, which is 1. This would give me 4 over 2, which is considered an equivalent fraction, right? These two are equivalent fractions. Remember that any number multiplied by 1, no matter if that 1 is 2 over 2 or 3 over 3, you're still going to get that same number. They're equivalent. And you could see that I could simplify 4 over 2 down to 2. So I have y equals -1/2 x plus 9/4. Whoa, no, 9/2. What did I do there that was so bad, right? When we're adding fractions, we add the numerators, but not the denominators. So this is the final slope-intercept form of our line. Now for numbers 3 and 4, I want to write the equation of a line with 0 slope through the point when x is 3, y is -3, and I want to write the slope of the line that's undefined with slope through 3 minus 3. Now remember that when you have an undefined slope, that's going to be a vertical line. And there was a tiny little caveat in our definition of point-slope form, and that was that point-slope form of a non-vertical line. So it doesn't work for a vertical line. But we still need to figure out how to find the equation of this line. So let's go to a nice clean space and we'll work through this problem. So I want to find a line with slope that's 0 through the point when x is 3, y is negative 3, and undefined slope through 3, negative 3. Let's focus on when our slope is 0. We know that's going to look like a horizontal line. So here is our point when x is 3, y is negative 3. It's right here. So a horizontal line would be y equals negative 3. But what if I wasn't quite so sure? Well, I could still use point slope form. I've got y minus a negative 3 equals 0 times x minus 3. So I get y plus 3 equals 0, so y equals negative 3. See, we found the same equation. That's why I always want to make sure when you're working with linear equations, think back and visualize what these are going to look like. You know, you can always sketch a tiny little graph. It doesn't have to be beautiful, but that's a great place to start. Now, undefined isn't something I can plug in to point slope form. So I'm just going to have to graph this point, and remember that a vertical line through that point has undefined slope, and this is when x equals 3. So the line is when x equals 3. Every single point on here has an x coordinate of 3, right? Every single point on this line is a solution to this equation. So this is the line x equals 3. Now, what if I wasn't given the slope, right? For the last 4 examples, I was given a slope, whether that slope be positive, negative, 0, or undefined. In this first example, I am given 2 points on the line. I'm given when x is negative 4, y is 3, and when x is 5, y is negative 7. Well, what I'm going to have to do first is calculate the slope. Remember, we know our equation for slope, and then I can use slope-intercept form. So let's go work on this problem, remembering that slope is y2 minus y1 over x2 minus x1, and I was given the points when x is negative 4, y is 3, and when x is 5, y is negative 7. And it doesn't matter which point is my x1 and which is my y1, we'll get the same answer regardless. So my slope is going to be my change in y, so negative 7 minus 3, over my change in x, so 5 minus a negative 4, so I get negative 10/9. Now I can put that into slope-intercept form. Remember, it does not matter which of these points I use. I'm just going to use this first one right here. That means I've got y minus 3 equals negative 10/9 times x minus a negative 4. Y minus 3 equals negative 10/9 x minus 40/9. I add 3 to both sides. Remember, 3 can be written as 27/9 if I wanted to find an equivalent fraction. That's where that came from. So I have y equals negative 10/9 x minus 40 over 9 plus 27/9. That's going to give me y equals negative 10/9 x minus 13/9. And there I have my slope-intercept form of an equation that goes through these 2 lines. This second example wants us to find the equation of a line parallel to that goes through negative 3, 6. That's parallel to 2x plus 3y equals 6. So remember that parallel lines have the same slope. So I'm going to get my slope from this equation. I have 2x plus 3y equals 6, and I need to solve for y. So I have 3y equals negative 2x plus 6. Divide both sides by 3. I get y equals negative 2/3 x plus 2. So negative 2/3 is going to be my slope. I had a point, negative 3, negative 6. So I can go ahead and set up my point slope form. That gives me y minus a negative 6 equals negative 2/3 times x minus a negative 3. So y plus 6 equals negative 2/3 times x plus 3. Y plus 6 equals negative 2/3 x. Negative 2/3 times 3. My 3's are going to cancel. It's going to give me minus 2. I subtract 6 from both sides. I get y equals negative 2/3 x plus 6. So this line right here is parallel to this line, but it goes through this point. You can see that they differ by their y-intercepts. So our final example involves finding the equation of a line through negative 3, negative 6 that's perpendicular to the line 2x plus 3y equals 6. So let's make ourselves some space. And it goes through the point negative 3, negative 6. We want it to be perpendicular to this line. Now, what is it true about perpendicular lines? Well, perpendicular lines, remember, if I take their slopes, I'm going to get negative 1. So this here becomes y equals negative 2/3 x plus 3, because we'd solved this one, sorry, plus 2, because we had solved this before, right? 2x divided by 3 plus 2. Cool. So now I have negative 2/3. So I want my slope, my line, to be perpendicular. So what do I multiply negative 2/3 by to get negative 1? Remember, we use the negative reciprocals. The reciprocals, it flips, it'd be 3/2, but we want it to be negative 1, so it's going to be positive 3/2. So this is our slope. I can now go ahead and use point slope form. I have y minus negative 6 equals positive 3/2 times x minus a negative 3. That gives me y plus 6 equals 3/2 times x plus 3. I have y plus 6 equals 3/2 x. 3/2 times 3 is just 2. I subtract 6 from both sides. I get y equals 3/2 x minus 4. So that's our final answer. This line is perpendicular to this one.